Hello everyone, welcome to Applied Chemistry Tutorials. Today's topic is molecular weight of polymers. Let's start with concept of average molecular weight. Polymers are composed of mixture of long chains of different molecular weight of nearly same chemical structure. Due to heterogeneity in chemical compositions, that is chain length, branching, end groups, etc., it is difficult to measure the exact molecular weight of polymers. Instead, average molecular weight of polymers are calculated. Suppose if M1, M2, M3, etc. are the molecular weight of different polymer chains in a mixture and F1, F2, F3, etc. are their respective fractions, then M bar equal F1, M1 plus F2, M2 plus F3, M3 and so on. Where M bar is the average molecular weight, Mi is the molecular weight of ith polymer molecule, Fi is the fraction of ith polymer molecule and summation of Fi from I equal 1 to infinity equal 1. So we can rewrite this expression as M bar equals summation of Fi Mi from I equal 1 to infinity. Now let's see number average molecular weight. Number average molecular weight or Mn bar is determined by number or mole fraction distribution of different polymer chains in a given sample. We have seen M bar equals summation of Fi Mi from I equal 1 to infinity. Then for number average molecular weight or Mn bar, it will be summation of Xi Mi from I equal 1 to infinity, where Xi represents mole fraction of ith polymer molecule. So we can expand this expression as Mn bar equal x1 m1 plus x2 m2 plus x3 m3 and so on. Now Xi equal Ni over N, where Ni represents number of moles of ith polymer molecule and N represents total number of moles. So we can write N as summation of Ni from I equal 1 to infinity. Now if we replace the Xi's from this equation utilizing this expression, then we can rewrite it as Mn bar equal N1 over N multiplied by M1 plus N2 over N multiplied by M2 plus N3 over N multiplied by M3 and so on. Now we can write it again as Mn bar equal N1 M1 plus N2 M2 plus N3 M3 and so on over N. Now we can replace N as summation of Ni from I equal 1 to infinity, and we can rewrite this expression as Mn bar equal summation of Ni Mi from I equal 1 to infinity divided by summation of Ni from I equal 1 to infinity. So this is the expression of number average molecular weight or Mn bar. Now Mn bar indicates most frequently present molecular weight in a given sample, and Mn bar is usually determined for low molecular weight polymers. Now let's see weight average molecular weight of polymer. Weight average molecular weight or MW bar is determined by weight fraction distribution of different polymer chains in a given sample. As we have seen, M bar equals summation of Fi Mi from I equal 1 to infinity. Then for weight average molecular weight or MW bar, it will be summation of Wi Mi from I equal 1 to infinity. This is small wi and it represents weight fraction of ith polymer molecule. So we can rewrite it as Mw bar equal W1 M1 plus W2 M2 plus W3 M3 and so on. Now small wi equal capital Wi over capital W, where capital Wi is the weight of ith polymer molecule and capital W is the total weight. Capital W is summation of capital Wi from I equal 1 to infinity. We can rewrite this equation by substituting small wi's with this expression and can write it as Mw bar equal capital W1 over capital W multiplied by M1 plus W2 over W multiplied by M2 plus W3 over W multiplied by M3 and so on. Again capital Wi equal Ni Mi. That means weight of the ith polymer molecule equals number of moles of ith polymer molecule multiplied by molecular weight of ith polymer molecule. Now we can replace this capital W's utilizing this expression and rewrite it as Mw bar equal N1 M1 multiplied by M1 plus N2 M2 multiplied by M2 plus N3 M3 multiplied by M3 and so on over capital W. And then we can write it as MW bar equals summation of Ni Mi square from I equal 1 to infinity divided by summation of Ni Mi from I equal 1 to infinity. This is the expression for weight average molecular weight or MW bar. MW bar has squared Mi term, so it favors higher molecular weight polymer molecules and is skewed to higher side of molecular weight. MW bar has higher value than Mn bar. Let's move forward to Z average molecular weight. Z average molecular weight or Mz bar further emphasizes high molecular weight fractions and introduces another Mi term for each fraction. So the Mz bar is now expressed as summation of Ni Mi cube from I equal 1 to infinity divided by summation of Ni Mi square from I equal 1 to infinity. This is not very common technique, only used for very high molecular weight polymers. Now let's see a general expression which can connect all these three different molecular weights of polymer. And the general expression is M bar equal summation of Ni Mi to the power j from I equal 1 to infinity divided by summation of Ni Mi to the power j minus 1 from I equal 1 to infinity. Now if we plug in the j value as 1, then this will be Ni Mi and this will be only Ni because j minus 1 will be then 0 and Mi to the power 0 will be 1. So the expression will be summation of Ni Mi from I equal 1 to infinity divided by summation of Ni from I equal 1 to infinity. This is the expression of Mn bar. So if we put the value j equal 1, we will get Mn bar. Similarly, if we put the j value as 2, we will get summation of Ni Mi square from I equal 1 to infinity divided by summation of Ni Mi from I equal 1 to infinity. This is the expression of MW bar or weight average molecular weight. Now if we put the j value as 3, we will get summation of Ni Mi cube from I equal 1 to infinity divided by summation of Ni Mi square from I equal 1 to infinity. This is the expression of Mz bar. So this general expression, if you remember and change the j value as 1 to 3, you can get all these three different molecular weight expressions. There is another type of molecular weight which is called viscosity average molecular weight. Molecular weight of the polymer is directly related to its viscosity. For high molecular weight polymer, viscosity will also be high and vice versa. Viscosity average molecular weight or MV bar is expressed as MV bar equals summation of Ni Mi to the power 1 plus alpha from I equal 1 to infinity divided by summation of Ni Mi from I equal 1 to infinity whole to the power 1 over alpha. Now alpha is a constant. If we put alpha value as minus 1, then we will get the expression of Mn bar. That means then Mb bar will be equal to Mn bar. If we put alpha equal 1, then Mv bar will be equal to Mw bar. So the value of Mv bar is in between the Mn bar and Mw bar. And the alpha value is usually in between 0.5 to 0.9. So we can rewrite this expression by substituting Ni multiplied by Mi as Wi. Mv bar equals summation of Wi Mi to the power alpha from I equal 1 to infinity over summation of Wi from I equal 1 to infinity whole to the power 1 over alpha. If we expand it, we will get W1 M1 to the power alpha plus W2 M2 to the power alpha plus W3 M3 to the power alpha and so on divided by W1 plus W2 plus W3 and so on whole to the power 1 over alpha. Now moving forward, another important parameter to characterize polymers is polydispersity index or PDI. It is the degree of heterogeneity or non-uniformity of a molecular weight distribution in a polymer solution. PDI can be expressed as mw bar divided by mn bar. That means it is the ratio of weight average molecular weight to number average molecular weight and gives the breadth of the molecular weight distribution. If PDI equal 1, then mw bar will be equal to mn bar. This represents monodisperse system. That means all the molecules have same weight. It is observed in some biopolymers such as some proteins or in some specially polymerized synthetic polymers. If PDI greater than 1, which is the usual case, then mw bar will be greater than mn bar. This is a polydisperse system and usually the PDI value ranges between 1.5 to 2.5 depending on the type of polymerization, but for some cases it can be very high also. Now in this figure there are two curves shown which are showing the molecular weight distribution. The yellow one has a higher breadth, so this is showing the high PDI of the polymer, and the blue one is showing the lower breadth, so this represents the lower PDI of the polymer. Although both the curves showing almost the same number average molecular weight of both the polymer system. Now let's see the molecular weight distribution curve. For the molecular weight distribution curve, it is a Gaussian curve. The x-axis shows the molecular weight and the y-axis shows the fraction of molecules. Now the most frequently obtained molecular weight is termed as number average molecular weight. It shows the mode of the Gaussian peak. If you want to know more about mean median mode, you can check out our video. The link is given here. Now mw bar is of course higher than the mn bar since it has a mi term extra in its expression. So this is in the higher side of the molecular weight. For mg bar this is further higher because this has another mi term in its expression. So it has mi cube in its expression. Now we have seen mv bar is in between mn bar and mw bar. So these are the four different molecular weights placed in a Gaussian curve which represents the molecular weight distribution curve of polymer. We can write it as mn bar less than mv bar less than mw bar less than mz bar. This is all about different definition and expressions of the polymer molecular weight. In the next video, we will show the example problems to calculate the different molecular weights of polymer. Until then, please stay tuned with us. If you like this video, give it a thumbs up, share and subscribe to our channel. Thank you.